Okay, so this is a video on graphing trig functions, but it's on once I have a, if I have a graph, finding the trig function, and I'm asking you here to find an equation both in terms of sine and cosine, and we're going to do a bunch of these in 6-7. So the next time we have a lesson, we'll talk more about that. So one thing I can find out right away from this graph is the amplitude, because I've got the highest and the lowest y values. So the amplitude is going to be equal to my max value minus my min over 2. So, and then that will also help me find my midline, which will give me my vertical shift. So I've got 7 minus -1 over 2, or 4. So if my amplitude is 4, then my midline is 4 away from the max or the min, so I'm going to draw that in. And because the max is at 7, then my midline is going to be at y equals 3, so that means my vertical shift is 3. So it doesn't matter which graph you start with. I'm going to start with cosine here. So I've got y equals 4 cosine. I'm trying to find that b value and that the c, my shift, and then my horizontal shift, that is, and then the vertical shift is +3. Okay, so let's now plug in some points. I have the point 947, so I've got 7 equals 4 cosine 9/4 b. So notice I'm plugging in 9/4 for x and 7 for y, minus c plus 3. All right, let's isolate the cosine. So if I subtract 3, I get 4. And then if I divide by 4, I get 1. So I've got 1 equals cosine 9/4 b minus c. So now if I go back up to looking at my graph here, so here's where the point is. And the question is, if cosine of what value gives me 1? Well, cosine normally starts at its high point and goes down. So it looks like this point should correspond to me taking the cosine of 0. And I know the cosine of 0 is 1. So that means that I have my angle here, 9/4 b minus c, should equal 0. Or in other words, c equals 9/4 b. Okay, now let's move to the other point. The other point is 2√3 plus 3. Sorry, it's 13/4, comma 2√3 plus 3. So my y value is 2√3 plus 3 equals 4 cosine 13/4 b, sorry, not x. I just plugged in 13/4 4x. So b minus c plus 3. And again, subtracting 3, so that will get rid of the 3, and then dividing by 4, I have √3 over 2 equals cosine of 13/4 b minus c. All right, so now notice it's important then to go back to the graph and notice that right after this point here, which I said was the same as if I were taking the cosine of 0, so that's kind of my starting point, then shortly after that, I get this point here. So if I think about in terms of quadrants, here would be 0. Right around my midline would be pi over 2 if I were graphing the normal cosine. And I'd be at my low point at pi. So if I'm still within this going down here, I should be an angle corresponding to quadrant 1. If I were over here, I'd be in quadrant 2, and so on. Knowing what quadrants you're in are important to figure out what angle here, when I take the cosine, would I get √3 over 2? And in this case, the first time it hits √3 over 2 in quadrant 1 would be pi over 6. So I have my 13 b minus c must equal pi over 6. And now let's go back to the fact that we had said over here that c equals 9/4 b. So let's plug that into this second equation here. 13/4 b minus 9/4 b equals pi over 6. And 13 minus 9 is then, 13 minus 9 is 4. So I've got 4b over 4 equals pi over 6. Or in other words, my b value is pi over 6. So if my b value is pi over 6, let me just move this up a little bit. If b is pi over 6, then c is going to be equal to 9/4 b, or 9/4 times pi over 6. Or doing this out here, let's see, I've got 2, 3, or pi over 3 pi, 3 pi, 3, God, I can't do this, 3, 2, 3 pi, sorry, long day, dividing by 3 first, so you've got 2, 3, and then, so 3 pi over 8, woo, that took longer than it should, okay, so, now going back to, let's put this into our equation, so, we've got y equals 4 cosine, and we just found that b was pi over 6 and x. And then I've got my c was 3 pi over 8. And then I've got the plus 3. Now, there was a little bit just in this particular, that's in general how you can always do this, by having these two systems of equations and being smart about finding the angles that give you that particular ratio, so you can set the inside of that trig function equal to that angle. And we're going to have more practice with this before, but I want to show you with this particular problem how we could have noticed something else. Now, notice here, if we factor out, we're still within the angle though, if I factor out a pi over 6, then I'm left with x minus, remember factoring out means dividing, so it's 3 pi over 6 divided by 3 pi over 8 divided by pi over 6, which means times 6 over pi. And simplifying here, I would get 4, let's do, I would get 3, so I'd have 9/4 plus 3. So what this means here, let's examine what this is saying here. So say I first, because remember when you do a transformation within the domain, you do reverse order of operations. So in this form, the first thing I would do is I would divide by pi over 6. So do the period change first and then shift over 9 pi over 4, which if I look back at the graph, that actually makes sense because at my graph here, notice normally cosine starts at 0 on the y, starts at its highest point when the angle is 0. But here it's been shifted to the right 9/4. So in this form, I could have originally, as long as I factor that b value out, I could have written x minus 9/4, recognizing that, oh, wait a second, I've shifted right 9/4. The reason you can't do it when it's in this form is in this form, you're saying, okay, first I'm going to shift it over this 3 pi over 8 and then divide by pi over 6, which totally changes things. So if you take in this second form, if I took care of the period first and then shifted, I can reflect the fact that it's been shifted to the right 9 pi over 4. So if you notice that you know the horizontal shift, just make sure that b value is factored out, that you're taking care of the period change first and then having the shift afterwards. But if you do bx minus c and the systems of equations instead, you don't have to worry about that, but I just wanted to point that out. Okay, last bit. I have one trig function. Let's go back. Let's use this. I've got one trig function. How then can I write it in terms of sine? Well, let's use the fact that sine and cosine have this cofunction relationship. So I can just say y equals 4 sine, and I'm going to say 90, or because I'm in radians, pi over 2 minus this angle here, plus 3. All right, let's simplify things up here. So pi over 2 minus, well, this is going to be minus pi over 6x. And then I have to do pi over 2 plus 3 pi over 8, which ends up being 7 pi over 8. So I've got negative pi over 6 plus 7 pi over 8. Well, you never want to give an answer with a negative b value, a negative in front of the x. So let's take care of that. So let's factor out a negative. Still within the angle here, though. If I factor out a negative, I've got pi over 6x minus 7 pi over 8 plus 3. And we know that sine of negative an angle, because sine is odd, is negative sine of an angle. So I'm just going to bring that in front of that a value, that negative. And this here would be my final answer for writing this in terms of sine. So you don't have to do systems of equations for both, in other words. Use the fact that you know the cofunction relationship.